Hello everybody, welcome to 8.1. We're on example 3. We're just hopefully going to finish this off in this video. We have the modeling of system of equations. So we have a scenario where there's a football being kicked and a soccer ball being kicked. So it says after a football is kicked, it reaches a maximum height of 14 meters and hits the ground 32 meters from where it's kicked. And it says after a soccer ball is kicked, it reaches a maximum height of 8 meters in the ground, hits the ground 38 meters from where it's kicked. The paths of both balls are going to show the parabola. So it says create an equation that represents the path of football. So I'm going to show you how to do it. I showed my grade 11 class how to do quadratic regression and the graphic calculators on an example. I'm going to show you in this course as well. And then I'm going to do it algebraically. I know we're in the graphing section, but just another way just to show you, because you'll be able to do this whatever way you wish on the test, unless it otherwise states specifically algebraic or using technology. So I have to come up with the equation first, right? You need an equation. So I've entered what to do here. You'll see it on your sheet, but what I'm going to do is I'm going to bring up the graphing calculator. All right, so when you're in the graphing calculator, what you're going to do is you're going to, I'll click back to the notes for a second. So I've come up with these 3 points. So I've sketched my block. I have 0, 0. It says it reaches a maximum height of 14, and then it hits the ground at 32. So the 16, I get that based on symmetry, the axis of symmetry, based on the 0, 0 and the 32, 0. You guys know how to do that. That's what we've done in the past. And that's where I've come with the 16. Okay. So now what I'm going to do is I'm going to do this method here, as you see on your screen on the graphing calculator, just to show you where you can get the equation in standard form. So you're going to bring up your graphing calculator. You're going to click Stat, S-T-A-T here. You're going to next hit Edit. So you'll hit Enter or 1, Enter. What we're going to do is we're going to put list 1. That'll be our x values. So our x values were 0 for the origin, and you can do it. You can do the corresponding point there if you want. So 0, 0. You'll see here that's your origin, or you can put all the x's, all the y's in. It doesn't make a difference. The next one we had was 16, and then another x value is 32, right? And the corresponding y value to 16 was 14, and the corresponding y value to 32 was 0. So we have only 3 points, and to get a quadratic regression, you will need a minimum of 3 points. Okay, and then you click. Once you have those points, and you'll hit Stat again, and then you go to hit the right here over to Calc. And then you go down to number 5, and you'll hit Enter, or you can just hit the number 5. And this is quadratic regression. And you'll hit Enter. You'll notice that X list, so your X values are coming from list 1. Your Y list is your Y values are coming from list 2. You don't have to worry about your storing. You can store your equation if you want to graph your function as well. And I'll show you how to do that. This is not necessary, but you can do that. What this does is it stores your equation in to your y equals, so you can graph it. So I'll do that. So if you hit vars, y vars, so you go to the right, hit function, and put it in y1, and hit enter. That just, what it does is it puts it in the location that you need. So we hit enter, and you'll notice you get, so quadratic regression will give you your equation in standard form. Gives you your A value, your B value, and your C value. Your C value was 0, obviously, because your origin was 0, 0, so that was your x and y intercept, the first one. There's your equation, so you would copy that down. You'll notice if I click y equals, it's here in the graph, and you can graph that equation there. Obviously, I'd have to fix my window. So my window, guys, I like to do a little bit of negative, so I'll go negative 4 and 32, and I'll go my scale by 8. And then my y went up as high as 14, so the negative 1 up to 15. And I'll scale that. Scale doesn't matter, I'll scale with 5s. Again, the scales are only going to have me, it goes up by a graph. You're going to graph that, and then you have that nice beautiful graph. Okay? I could have went my window just to get a little more y. I could have went 36 or 35. It's fine. Doesn't make a difference, like I said. 5, 4.5, like I said. It doesn't make a difference. Right? We're only interested in quadrant 1. That is the path of the football. Alright, so getting back to your equation there, on your screen, go through it again quickly. Stat, calc, stat, calc, go down to quadratic regression, enter list 1, list 2, y, your vars, y vars, function, and it's y1, and calculate, and enter, measure function. So you copy that down, you'll notice I have that on your page. I've added that right here. Okay, there's your information, and there's your equation. That's the equation of this line right here. Pretty neat. Pretty cool little method. I'll do it again, and you can do it again with the other one if you wish, but you don't have to. So then I did the second one. I did algebraically. I know it's in the graphics section, but I did algebraic because you guys know how to do this. This was a soccer ball. It said it had a maximum height of 8, 38, so therefore it was 19, and 8 was your vertex. So we put it in vertex form with my a value, and there's my equation. And you can put that equation in your y2, and I'll put that in. So bracket negative 8 divided by 361, close my bracket, x, oh sorry, open my bracket again, x minus 19, close your bracket, squared, plus 8, there we go. Graph, there's your second equation. I have to open the window up a little bit because that one's 38, so bring this to 40. Again, you can easily fix your window, right? Graph, there's two graphs. System, they both start at 0, 0, so that's obviously one solution. And then the other solution we're looking for is where the two lines intersect. This is the bottom part. And we'll go second function, calc. Calculate the intersection point. Enter. So blue graph, go closer, enter, jumps to the second graph, and enter it the third time. And they intersect at a horizontal height of 27, horizontal distance of 27.9 and a vertical height of 6.24 meters. And if you go back to your sheet, so I solved the 2x2 system using the graphic calculator, and there's lots of points, lots of information. There's your Desmos graph, and there's lots going on. The blue path was your football, and the red path was your soccer. Okay. Your intersection points on the graphic calculator are your solution. So the ball's at a horizontal distance of 27. Okay. Let's move on to example 4. I know example 4 is not a lot of favorite questions. You guys don't like these for some reason. Not just you guys. I find them historically we don't like them. But just read the question, set up in equations, and then go from there. So I let x equal to first and y equal to second number, and then I set them equal to y. Again, that's not always going to work, but it's up to you. You call it AB, it doesn't make a difference. I just set it up knowing that the first number was going to be a quadratic, so that was just me being, thinking ahead there. But again, it's up to yourself. So it says two numbers are related. The first number is 12 minus. The first number minus 12 is equal to the second number. So first number minus 12 is equal to the second number. I rearranged for y, which was already really set up for that. The second one, it says the square of the first number, so I squared it, minus 30 times the second number, 30, subtract 30 multiplied by y, is equal to 360, then I set it equal to y2, so I subtracted the x squared from both sides, and I divided both sides by negative 30, so that's why it was negative x squared divided by negative 30 becomes positive, and then the positive 360 divided by the negative 30 became this. Alright, so I have my two functions, y1, y2, plugged them in my graphing calculator. I get the two intersection points as you can see on your screen. This is the Desmos. I will do it on the graphing calculator with you now. And there's your two intersection points, 0 and 12, and 30 and 18. So those are the possibilities for your numbers for your x and your y. Those are your two possibilities that you can see there, right? Pretty interesting. So it means your first number could be 0, your second number could be negative 12, and your first number could be 30, and your second number could be 18 in order to satisfy both of these equations. I mean, we can find any two numbers to satisfy the linear, the y1 here, but the second one, it will only be those two examples there. Okay. And then there's textbook questions that you're going to work on right here, page 435, numbers 9 and 15. So we've got a few more minutes left for the video, so I'll go up there and I'll do this on the graph. So remember, you want to set up your graph, y equals clear, and clear, y1, the first one was x minus 12. Second graph was bracket x squared divided by 30, close my bracket, minus 12. Bring my graph, please. And notice the window's obviously not big enough, so I'm going to zoom this out a bit. So negative 20. We don't need that to be that small, so I can actually make that negative 5. My y, I go all the way over to 30, so 40 is good. Go by 5s. My y min went down to negative 12, so I'll put negative 15 in. Went up as high as 18, so 20 in. Scales 5 is fine. It's good to see the 2. This intersection point here, we'll do both. Second function calc, intersection point, enter. So to the left, all the way down here, enter. It's already jumped down, enter for the third time. So this here, remember, this does mean 0. You get this e to the negative super small. So this 0, negative 12. And you can see that, I'll show you that in table values in a minute. Second function calc again. Go down to intersection point. And go all the way up, which is going to the right. I say up, go to the right. Enter for the second time, enter for the third time, it's 30 and 18. And you can see that in the table, 0 and 12 there, right? And scroll down to 30 and 18. Both right. So y1's the first, second, and they are equal. But when you're showing your solution on your page, just do a quick sketch, show the two graphs, you can see the linear line, you can see the quadratic, and the two solutions. That's it. And then your homework there as well. So, hope you're enjoying the videos. That's it for 8.1. We'll pick it up at 8.2 in the next video. Thank you.